Welcome to the session, how you can transform unstructured data to gain a competitive advantage using AI SQL. My name is Jessie Felix. I'm a product manager here at Snowflake. Now, I've worked in data and analytics for over 10 years, and I've spent a good share of that time working with organizations' data strategies. So I know full well that one of the hardest challenges in data processing is how to get value from unstructured data. And this is why, even though the majority of the world's data is unstructured, it is the least analyzed and the least used today. And that's one of the reasons why I'm so excited about AI. Just very quickly, my mental model when I think about AI is that I think of it as a tool that makes it possible to process all data, multimodal data, from text to documents to images to audio to video, all of which was previously difficult to analyze without specialized NLP or vision scientists, for example. So put simply, the amount of data that you can now analyze has massively expanded. And so too, an opportunity to really up-level your analytical-based applications and your organization as a whole. And one of the key things at Snowflake is that our mission is to help you unlock the full potential of all your data. And that is why a key focus for us is making it easy to bring and analyze structured and unstructured data together in one place. Whether your data is coming from data lakes, from various applications, Snowflake makes it easy to ingest, to transform, and to govern all of your data. And by keeping the data in place and applying AI where the data already lives, you keep control, scale, security, and cost efficiency. And what this is really doing and what we're seeing across our customers is that it's really enabling customers to build what I like to call next generation applications that are able to combine structured and unstructured data that unlock insights that truly understand business context. So, for example, we see many customers building customer care applications, for example, that analyze sentiment on call transcriptions. We're seeing customers build supply chain workflows that automatically reconcile supplier contracts. We're seeing customers build better personalization systems that are able to analyze user responses based on different ad creatives to increase revenue for their organization. Or we're seeing customers automate compliance workflows that process contracts and playbooks to ensure that every decision meets regulatory standards. To provide you with a practical but what I think, very powerful example, how you can get value from unstructured data, we have Nissan. So Nissan is using Cortex AI to build a customer analytics application that allowed them to understand the characteristics of high-performing dealerships to make action plans to improve the remainder of their stores. And core to that was being able to efficiently process millions of customer reviews and surveys and getting high-quality sentiment analysis. So how can you build next-level applications in Snowflake? The answer to that question is AI SQL. AI SQL is the AI query language that is transforming how organizations work with unstructured data. Every day, AI SQL keeps thousands of customers' AI workloads running. It regularly processes millions of inference calls, and it scales to trillions of tokens. It powers everything from customer 360 analytics, post-call analytics, to document processing, and various personalization workloads, all while keeping a familiar SQL workflow. The way that you should think about AI SQL is really as the foundation for all multimodal analytics. You get instant access to leading LLMs from OpenAI, Anthropic, Meta, Mistral AI, without any infrastructure headaches whatsoever. All of that is managed by us. And your data never leaves Snowflake. So the security and the governance remain fully under your control. We also offer fully managed AI SQL functions that deliver industry-leading quality and performance. Whether you need to classify text or images, you can use AI Classify, which is designed to deliver high-quality labeling accuracy. Simply define your labels and point them to a table or a library of images, and you get a classification. Or if you need to easily transcribe lengthy audio files, use our AI transcribe capability that allows you to efficiently transcribe audio at scale. It's fully managed and includes word level and speaker level segmentation. Or if you need to extract information from various documents in a structured way, you can now use AI Extract to easily get structured information from any unstructured data, really, including text, including images, and documents. Simply define your output schema using simple labels, typed objects, for example, or a JSON schema. We make all of this and more possible through SQL. AI SQL, in addition, enables different semantic AI operations on multimodal data using familiar SQL syntax. So you can now filter by meaning rather than keywords, join tables based on visual similarity between images, aggregate insights on unstructured content across hundreds to thousands of records. AI SQL transforms how you query data by understanding context and semantics. So let's look at very quickly at a real world example. So let's imagine that you want to answer the question, what is the yearly revenue growth and market outlook for companies that have recently undergone a CEO change in a specific sector? So in yesterday's world, the way that you would build this is through a multi-step pipeline. You would first extract and classify various company descriptions. You would then match various research reports to companies, finally aggregating insights manually, usually from what I observe from various customers. With AI SQL, this complex analysis becomes a single SQL query. AI filter semantically identifies energy companies with the recent CEO change from unstructured text. AI Ag will summarize market research insights, and semantic joins will connect to database to different data sets based on their meaning. The result here is you have one query, you have multiple data sources, and intelligent insights. And that simplification means that you can really extract insights so much faster than before. So we benchmarked common AI tasks like aggregating summaries across transcripts or labeling various support tickets. And what we find is that using AI filter, for example, in our AI join operations, you're able to deliver significant performance improvements in end-to-end workflow runtimes, up to 7 times. We manage the infrastructure and handle the heavy lifting for you so that your team can focus on insights, not infrastructure or stitching together various complex jobs. In addition to making AI SQL functions easy and performant, they're also built for high quality so that you can deploy to production with confidence. So for example, AI sentiment, it delivers state-of-art performance for overall and aspect-based sentiment analysis. AI Translate matches state-of-art quality at a fraction of the cost with reliable multilingual outputs. AI Transcribe achieves the lowest word error rate in the market for long audio files of up to 2 hours, for example, and supports multi-speaker identification, timestamps, and you're able to integrate it directly with your internal and external storage locations. So this isn't just about convenience. It's about deploying AI functions that you can trust at enterprise scale. And now with AI Extract, actually, we're setting a whole new standard for key information extraction. AI Extract delivers the highest zero-shot accuracy for precise extraction of entities and tables for various documents. It doesn't require any complex orchestration, as this is really a one-stop type of operation. So again, this isn't just about convenience. This is about very powerful functionality that you can go to production with confidence. So for today's demo, I want to show you how we can turn hours of raw call recordings into actionable insights automatically using AI SQL. Many of our customers today using AI SQL build end-to-end customer 360 analytics workloads. A very common use case that we observe is post-call analytics. And today, I'm proud to say that you can do all of this in SQL using our different capabilities. So there's typically 3 steps in a post-call analytics demo at a very high level. So first is the actual audio transcription, as well as some PI redaction that customers perform. Then we go into various transformation tasks that can include anything from extracting key information from various calls to classifying various calls and analyzing sentiment, in some cases translating those calls as well, before we get to deriving insights from all of the metadata that you extracted from these different calls. So for today's demo, I'm going to imagine that I work for a customer support analytics consultancy, and I am the analyst responsible for understanding different issues across our various customers. So for today, we have a new customer that has various call recordings, and they want to understand various questions from various audio files, such as what is driving the majority of their call load, how many issues are being resolved, are the customers satisfied, and are there any improvements to their service that they can make. So luckily, as an analyst using AI SQL, I don't need to rely on any platform engineers or any additional technical expertise within my organization to integrate a transcription service with the different audio files that we're going to process. So very easily in Snowflake, you can create an internal or an external stage where you can effectively point to files that are stored internally or externally. And the key thing there is that whenever you use AI SQL, there's no copying of those files into Snowflake. We do all of the processing in place, and all the extracted information is stored in a Snowflake table. So for today's demo, we're going to look at different audio files that are stored in an internal stage. So for our first step, we're going to actually transcribe the call. So we're going to very easily, as you can see here, use our two-file data type capability that allows us to store references of files in an internal or external stage. And then we're going to use our AITranscribe function that will reference the files in the stage. And one of the things that I talked about earlier is that our AITranscribe function allows for 3 modes effectively. So the transcription of the audio files, which is just a text transcription. We also support word level segmentation. So if you want a timestamp for every word in the audio file. And then we also support speaker identification. So if there's multiple speakers in a call and you want to classify the different speakers and segment them in the response of AITranscribe, you can also do that. So for today's demo, we will only be using the standard text transcription. So what you'll see here in the response within our transcription results is that it will return an object. It will return an object with the audio duration in seconds, and then it will return the transcribed text. So the AITranscribe capability is multilingual. It supports various languages. So as you can see in this example, we're returning one record that happens to be in French, but there are also other records that are in English. Now, one of the things that we talked about that is very common with our various customers is needing to redact information, PI information from these various transcripts before they do any additional analytics. So even though we have now effectively a table with our audio file and our raw transcription results, we can't use this quite yet. So this is why we need to redact the PI information. So we're going to add additional columns to our view. So we're going to add a transcript redacted column. And the way that we're going to create this column is that we're going to use for this example, at least, we're going to use the AI complete function. And we're going to use a Claude Sonnet 4.5 model, which delivers very high accuracy for various classification tasks, and will do very well for this PI redaction task in particular. We're going to keep it very simple today. So the prompt that I'm going to use is look at the transcript, and if you identify any PI data, mask it. There's more specific prompts that we could build, but for the purposes of efficiency, we're just going to pass a very simple PI redaction task. So that's now complete. So now we're going to look very quickly at what the results look like. So we're going to compare the actual transcription results to the redacted column that we just created. So let's just grab one very quickly just to see what it looks like. So we see that it's masking the name of the customer, and we see here in the sentence that it's also masking the account number of the customer. So if you see here where the agent asked to identify the account number or the last 4 digits of the number, our function is properly masking that information. So for the sake of time, we're going to move on. We've looked at the results of this redaction, and we think it's high quality. So we're going to create a table looking at only processing the records that have been redacted. So now we have what we're calling a call recordings clean table, which includes effectively the audio duration and the transcripts with the PI redaction in place. The next thing that we're going to do is, since we have no information about this customer, we need to add a bunch of metadata to really understand like the shape of this business. We can do all of this within AI SQL with a few functions. So the first thing that we're going to do is that we're going to organize the types of calls based on the different services that are offered by this customer. We know that they have a brokerage division, a checking division, all the way to mortgage, loan, mutual fund, and insurance services that they provide. So we're going to create a classification of the product services using our AI classify capability. So how AI classify works is you effectively define a label, you point it to a corpus of text, in this case, the redacted transcript, and it'll give you very quickly, as you can see, a classification based on those labels and based on that text. Now, AI classify also has the ability, in addition to provide different descriptions and to provide different examples if you want to further anchor and provide more clarity to the model how that classification should be performed. So now we have a table with the audio duration, we have the transcript that is redacted, and now we have all of the products that were mentioned. So we have an idea what services customers are calling about. So just to do like a very, very fast analysis, I'm just going to run a quick count by. And we see that the majority of the calls, and let me just run that again with the descending just so I can show it from most to least. And we see that the majority of the calls are coming for our credit card services. So that's information that we know. So one of the questions that I asked in the beginning is, what is driving the majority of the service calls? So we have an answer to that. We don't have the full picture. So let's add a little bit more information to this. So we're curious, like, what are the types of problems that customers are facing? So we're going to continue to use the AI classify function. So, and the prompt is which product is mentioned in the following transcript is what we're going to pass. And we're going to provide a list of most frequent issues that we've observed in our organization, from asset reallocation to account access to fraud, for example. So let me run that very quickly just so that we get those labels. And now we're able to get a little bit more flavor of what is happening in this business. So now we have a table with the audio duration, the transcripts redacted, and now the new issues that are mentioned. So for this particular call, there was account access, credit card, and transaction issues. So as you can see, there's multiple issues. And a key thing that I might have skipped actually is that we're using on the output mode multi in AI classify, because it allows multi-label classification. So let's revisit the question of like what drives the majority of the service calls. So I'm just going to do another quick aggregation here. And what we find is that the majority of the issues that customers are calling about are related to transactions and account access. Okay, that's interesting. So moving along, let's figure out how successfully are we handling different issues from the different inbound calls that we get. In order to answer that question, I'm going to very simply use our AI filter capability, which allows us to apply a semantic filter. So as you can see, the AI filter takes in a prompt. So I'm simply asking, has the customer problem or request been fully resolved? And what it's going to do is it's going to return a Boolean effectively, which will be true if it's been resolved and false if it hasn't been resolved. So let's very quickly analyze the results. So interestingly enough, we see that the majority of the inbound calls are actually not resolved, which is alarming for a business, I would think. And it also begs the question whether our customers are satisfied, actually. I think we can all guess whether we have a lot of satisfied customers when the majority of the issues are not resolved. But that's just intuition. Let's use the AI sentiment function to understand the overall sentiment. But also, I'm also interested on the call agent sentiment, as well as the client sentiment and the sentiment about the product satisfaction. Just as a quick reminder, the AI sentiment capability allows you to get overall, but also granular aspect-based sentiment analysis. So you're able to define different aspects of a content. So in this case, we're looking at transcripts. So you can identify other things like professionalism, for example, the agent's competency, for example, or if you're looking at product reviews, you can define very granular aspects, and the AI sentiment function will return the overall sentiment every time in the response, but also the sentiment for those aspects that you define. So very quickly in the response here, so now we have in a JSON object, you can see that the categories, we have the overall sentiment, we have the sentiment for the agent and for the client, and then we also have the product satisfaction. So for this particular record, it looks like the sentiment is negative. Let's look at what it says. Well, it's in French, and unfortunately, I don't speak French. But let's look at this one, for example. So this one is also negative, and it looks like, just doing a quick read here at the bottom, it looks like so it looks like it wasn't a resolved issue and that the agent had to transfer the customer to somebody else. But that's very high level. So let's do a account analysis just to get a sense for, like, overall how many customers are satisfied versus those that are not satisfied. So let's run a quick query here. Huh. So unsurprisingly, the majority of the calls actually have negative sentiment. So now we know two things. Well, we know several things, but we know that the majority of the calls are not resolved. And we also know that the majority of the calls customers have, there's negative sentiment associated with the vast majority of these calls. So let's try to understand whether there's a correlation between resolution and sentiment. So intuitively, it makes sense, but let's try to understand whether that actually holds up once we look at the data. So let's run this query that allows us to kind of like map these things very quickly. So very interestingly, what we see here in these results is that for all of the calls that have negative sentiment, they're all unresolved calls. So that gives us a very strong signal that there is a relationship between not resolving a call successfully and that call having negative customer sentiment associated with it. So what can we do to improve the resolution and customer satisfaction for this customer? Well, let's try to understand which products are actually driving a lot of this negative sentiment. So earlier we saw that the majority of the calls are driven from our credit card services. So let's understand whether those are the calls that are being unresolved and driving potentially negative sentiment. And what we see from these results is that the majority of the calls that are unresolved actually come from our mortgage services. In fact, in this particular data set, there's no resolved calls. So what can we do to improve? So now we know that the majority of the customers where there's unresolved calls and have negative sentiment are primarily potentially stemming from our mortgage services. So what can we do to improve? So to answer that question using our AI SQL capabilities, I'm going to use our AI ag operator, which effectively allows you to ask questions on columns and on tables and views of data. So I'm effectively going to point AI ag to the transcript table that we have just created and to the call recording table that we just created. And then we're just going to ask it in a simple prompt, like, what are the top 5 things that we can do to improve customer satisfaction? I'm asking it to return a bulleted list in English, and I'm going to filter for the mortgage department, just to be very clinical. And we have our results. And the AI, and based on the AI act function, there's several action items that we can take back to our leadership team. We can improve communication and transparency. It seems like our customers are not well informed. It seems like our technical systems have a lot of errors. And it seems like there's some issues around providing timely and effective solution to customer problems. And very interestingly enough, and you can take this one back to the customer to make organizational updates as well, is it seems like the customer service representatives do not have the right level of authority to resolve various issues for customers. So there's a lot of problems in terms of reducing the need for escalations and transfers. And one of the things that you will notice is that in these past couple of minutes, just having a conversation with you, using AI SQL, we've been able to process effectively 100 calls or so of audio files, and we've just been asking granular questions of data, of unstructured data using AI SQL. There's really no complex integrations that have been required. And this is really powerful for analysts in your organization that are now empowered to very directly process unstructured data from their organization. So in the last couple of minutes, we've transcribed various audio files, we've redacted PI, we've classified products and different issues and analyzed sentiment, all with simple SQL queries. My biggest takeaway for you is to transform all of your data with AI SQL. And very specifically, actually, the unstructured data sitting in your organization is no longer a barrier. You can start analyzing it today. You can start getting value from it today. And a very powerful thing is AI SQL's ability to democratize intelligence across a broader population of data workers. So it's no longer the days that you need an NLP or a vision scientist to do very specific audio analytics or vision analytics. You can do all of these things today using our AI SQL capabilities. And a key thing that we're observing is the power of taking unstructured data and giving it structure and even joining it with your structured data. And all of this you're able to do inside of Snowflake, and you can govern and analyze all data types on a single efficient platform and applying the AI where it already lives. Thank you for your time. I'm looking forward to seeing you use AI SQL and building next generation applications that take unstructured data and structured data to get more business value, and at the same time allowing your organization to move faster.